Hi, Algebra 1. This is page 89 and 90 all worked out. Okay, so first one we want to do is we have a 3 here and we have a 5 here. We have an open dot going this way. We have an open dot going this way. This is an OR problem, so we want overlap. No, overlap doesn't matter. So my answer is going to be negative to positive infinity. And on this one, I have a 3, and then I have 5, so I want greater than 3, less than 5. This one, I want overlap, which is here, so it's going to go between 3 and 5, both parentheses because they're open dots. Then I'm going to go from 3 to 5. I'm going to have a solid dot here and a solid dot here. I'm going to shade in between the two. It's an AND problem. I want overlap because this would have gone this way and this way, which is going to be hard bracket 3 to 5, or that square bracket. And then I have, again, we're using a bunch of these that are all the same. So going this way, going this way. There's no overlap, it's and, so this is a no solution. And changing the numbers finally, 6, 0, and 6. So 0 going this way, that's going to negative infinity. 6 open dot going this way, that's going to infinity. This is an OR, so my answer is going to be negative infinity to 0, and then 6 to infinity. Now I have a negative 2 solid. That's going this way. I have a 6 open dot going this way. The reason I didn't go to the infinities is I realized it was an and. I'm looking for overlap. I don't have overlap. That's no solution. And I have negative 2 here, 6 here. Solid dot at the negative 2 going to the negative infinity. The reason I put that is because there's an or. Open dot and the 6 going that way to infinity. So this is going to have two answers. That's a square bracket on the 2, and then a parenthesis on the 6 to infinity, because I have an equal sign on the 2. That's why there's a square bracket. Then I have negative 6 down here, open dot going this way. I have and a negative 2 here, so it's going to be a solid dot going this way. It's an OR, so all the overlap and wherever the line goes. So this is infinite solution, so it's negative to positive infinity. And then I have a negative 6 here. I have a negative 2 here. Open dot on the 6, solid dot on the 2. This one I want overlap, which is this, so it's going to be a soft bracket or a parenthesis on the 6. It's going to be a hard bracket on the negative 2. I have 5 and I have 7. I have a solid dot on the 5. That goes this way. I have a solid dot on the 7 going this way. I want overlap. So this is going to be square brackets on both because they both have equal signs. I have a 5 here. I have a 7 here. There's going to be a solid dot going this way. This is going to be a solid dot going this way. It's an OR problem, so wherever the line exists, even on the overlap, so negative to positive infinity. I have a 5 here, open dot going that way. I have a 3 here, my mistake, going this way. It's an AND problem, so I want overlap. There's no overlap, so this is no solution. All right, solve the compound linear inequality, write the solution in interval notation, and draw the graph. All right, so I'm going to add 5, add 5. So that gives me x is less than 13. I'm going to flip this one over, including the sign, to get the x on the left side. Divide each side by 2. So x is greater than 10. So if I have a 10 here with an open dot and a 13 here, going this way with an open dot, it's an OR, so I want the entire line, so it's negative to positive infinity. I'm going to flip this problem entirely over, including the sign. Subtract 4 from both sides. And then divide both sides by 2 on this next one. So if I have a negative 15 here, and I have a negative 8 down here, 0 is way, way over here. All right, this is going to give me an open dot at the 15 going right, and this is now going to be a solid dot on the 8 going right. So again, this one's kind of weird because the arrows are both going the same way, but it's an OR problem, so I want wherever the line exists. So it goes from parenthesis negative 15 to infinity. All right, this one, I'm going to subtract 7 from both sides, so I get -2. I'm going to divide both sides by a -9. So remember, when I divide by a negative, it's supposed to be a 9, the sign itself flips over, so that's going to give me 5. So I have an open dot at the -2 going this way. I have an open dot at the 5 going this way. This is an OR problem, so that goes to -infinity, positive infinity. So my answer is -infinity, -2, soft bracket, or parenthesis, and then going from the 5 to infinity. That was an OR problem. Again, we just want to where the line exists. Problem 16, I'm going to go ahead and distribute the half over the parentheses here and here. Half of 2 is 1, so I get 1x or just x. Half of 10 is -5. I'm going to add 5 to both sides. On this one, I could probably get away with doing the 3/4 over the parentheses. 3 times 4 is 12. 12 divided by 4 is 3, so I get 3x. 3 times 12 is 36. 36 divided by 4 is going to be 9. Add 9 to both sides. Divide by 6. This is an OR problem, so remember we're looking for just overlap, so I go 6, open dot this way. That goes to -infinity. 10's right here, open dot going this way. That goes to positive infinity. I'm going to have 2 answers because it's an OR problem. Looks like that. For problem number 17, let's subtract 2 from both sides first. That gives me a 3. Divide both sides by 3, so w is less than 1. I'm going to subtract 8 from both sides, and then I'll multiply both sides by -1. If I multiply by -1, the sign has to flip over. So now I'm going to go ahead and put it here. I have a 1, I have a 6, I have an open dot at the 1 going left, that goes to -infinity. I have a solid dot on the 6, goes this way, so that goes to positive infinity because it's an OR problem. The word OR is right here. It's going to go from -infinity to 1, soft brackets or parentheses on both. Hard bracket on the 6 because it's a solid dot, also has the equal sign, to infinity. Problem number 18, we're going to distribute the 2 over the parentheses, so I get 2 minus 2x is greater than 6. Subtract 2 from both sides, so I get 4. Divide both sides by -2, so if I do that, the sign has to flip over. And then I'm going to distribute -2 on both on this, so I get -2 times x is -2x, -2 times 6 is -12, is less than -12. I'm going to combine 4 and 12 together. They're on the same side, so that's -8 is less than -12. Add 8 to both sides. That's going to give me -4. Divide both sides by -2, so the signs are going to flip. So that's going to give me, that's -2, right? So that's going to give me a +2. This is an OR problem as well, so I get -2, open dot going this way. 2 is right here, open dot going this way. Remember, this is an OR problem, so we're going to have 2 answers. So I go -infinity to -2, soft bracket, and then I'm going to go from 2 to infinity, also soft brackets or parentheses. Oops, I went a little too far. All right, so now we're going to get back to our absolute values. Let's look at this a little bit differently. Let's divide both sides by 2 first. Let's not worry about finding that middle term right now. Let's just go to 6. Basically what I can do is I can now create 2 different problems. Oh wait, it's equal to a negative. Absolute value all by itself equal to a negative is no solution. Wouldn't work. For problem number 20, we're going to go the same approach. Subtract 4 from both sides, so I get absolute value of 2x minus 7 is equal to 5. Now we're going to create 2x minus 7 equals 5, and 2x minus 7 equals -5. Go ahead and solve both. Add 7 to both sides. That's 12. Divide each side by 6, or 2 to get 6. I'm going to add 7 to both sides. And then I'm going to divide each side by 2. So there's my 2 answers there. Okay, we're going to be in our workbooks in a moment. Okay, I'm now on page 91 of our book. So get there. So let's take the inequality. So this is going to be x is less than -2. This is going to be x is greater than 3. We're going to write it in interval notation. So these are pointing out to infinities. I would say this is going to be an OR problem because it's shading away. So my interval notation is going to go from -infinity to -2. Soft brackets on both. 3 to infinity. There's our answer. This next one I believe is going to be an AND problem. Okay, so I'm going to go x is greater than -2, x is less than 3. So I want to put this together as a compound inequality. Okay, so what I'm going to do is this side's fine. I'm going to flip this over. So I get this. Notice how that just happened. This only works on AND problems. Okay, I'm going to put the x's together to make it one problem. So it looks like that. This is actually the inequality. This is what AND problems are going to start looking like. OR problems will always stay separated. And so then my answer is going to be from -2 to 3. And it's going to be a parenthesis on both. So that's my interval notation right there. Problem number 3, this also looks like another AND problem because it's overlapping. So I want x is greater than -4 or equal to, because it's a solid dot, and x is less than or equal to 0. Solid dot on both, so you have to have the equal sign. Whatever's on the left side, you're going to flip over the equation to make it look like this. And then I'm going to bring this straight down and look like this. So here's my inequality. Again, because it's an AND problem, it's got overlap. We can put them together. You can't put OR problems together. My interval notation is going to go from -4 to 0, and I have a square bracket on both because both of those were solid dots. Let's see, is there anything here? No, that was... All right. So this one, let's break this apart. This is 2 problems. So here's my first problem. Here's my second problem. Notice the middle went with both. Now I'm going to go ahead and flip this problem over to work it. Add 2 to both sides. And then I'm going to take it. So then this one I'm going to add 2 to both sides here. So I have a 2 here. I have a 7 here. It's going to be an open dot at the 2, or a solid dot at the 2 going this way. It's going to be a solid dot on the 7 going this way. This would have been an AND problem. When it comes and it looks like that, and this middle part goes with both, this automatically turns it to an AND problem. So that means AND means I want overlap. So my interval notation is going to go from square bracket 2 to square bracket 7 because they're both solid dots. Remember, they both had the equal signs. Go ahead and turn over to page 92. This is going to be an AND problem, so I'm going to break it down. The middle goes with both parts. Okay, I'm going to flip this first one over, including the sign. Go ahead and solve it. So I'm going to subtract 4 from both sides. So that gets me to -16. Divide both sides by 2. So x is greater than -8. The sign didn't flip over because I only divided by a 2, not a -2. Second part, I'm going to subtract 4 from both sides. Divide both sides by 2. So this is going to go from -8 to +8. I want a solid dot on the 8, and it's going to go to the right. Remember, the arrow points the direction we go. And I want an open dot on this 8, and it's going to go this way. This is an AND problem because this was together. It has to be AND. So it's the overlap. So where does the overlap exist? Well, it's a hard bracket on -8 and a parenthesis on 8. And there's our answer. For this problem, let's separate it into 2 things like we've been doing. Remember, the middle goes with both. You create 2 problems. This is going to be an AND problem because it's put together. Let's flip this one over. The sign flips over because I turned the whole problem over. Distribute 2 to both of those, so I'm going to get 6x minus 2. I'm going to add 2 to both sides, divide by 6, and then let's do the second one. Let's distribute the 2 over the parentheses. I don't have to flip this side over because the letter's already on the left side. So I get 6x minus 2 is less than or equal to 28. I'm going to add 2 to both sides, divide by 6. So I'm going to go from 1, and that's going to be an open dot going this way, up to 5, and that's a solid dot going this way. Remember, it's an AND problem because it was put together like this. This came as one problem. I'm looking for the overlap. So I'm going to go from 1 to 5. The 5 has a hard bracket. The 1 has a parenthesis. Okay, so we're just going to finish up these problems. So again, I want the problem to break into 2 problems. The middle goes with both. I'll flip over this one first before I start solving anything. The sign flips over. Let's go half of each of those. Half of 14 is 7. So I bring the x, and half of 9. Half of 9, if I go 9 divided by 2, I'm going to get negative 4.5 in this case. I'm going to add 5. Okay, so I'm going to add 4.5 to both sides. So that's going to give me 9.5. And then we're going to divide both sides by 7. And 9.5 divided by 7 is going to come out to, as a decimal, of about 1.4 rounded up. It looks like 1.357, so rounded up. Distribute half, so half of 14 is 7x. Half of 4. Oh, you know what? I made a mistake. That's supposed to be a 4 right there, isn't it? That should have been a 2. I'm sorry, I made a mistake. Add 2 to both sides. That's 7x is less than or equal to 7. If I add 2, divide by 7, x is greater than 1. And then I'm going to go half on each of those. 7x minus 2 is less than 12. Sorry about the mistake. Add 2 to both sides. Divide by 7. So if you put this on a number line, you have 1 here, solid dot going this way. 2 here, open dot going this way. It was put together. It's an AND problem. So my answer is going to be square bracket 1 to 2. And then the 2 has a soft bracket. This one's an OR problem because the word OR is there. So OR will be part of the problem when we have this. So I'm going to subtract 1 from both, or I'm going to flip this whole problem over first. Flip the sign over. I'm going to subtract 1. So negative 8 minus 1 is negative 9. Divide both sides by 3. So I get negative 3. The sign doesn't flip because I only divided by a number. I'm going to divide both sides by negative 5. The sign flips over here because I divided by a negative 5. 25 over negative 5 is negative 5. So if I put that on a number line, if I had negative 5 here, that's an open dot going this way. Negative 3 is over here. That's an open dot going this way. Remember, this is an OR problem, so we can look for where the graph exists. So negative infinity to negative 5, soft bracket or parenthesis, negative 3 to 8. Okay, all the rest of the problems are relatively done the same way. So for Friday, I would like us to work on, I'm not going to worry about these last 2 problems. We're going to work on page 93 and 94. And I think you can do 1 through 17, all of them. Have a nice day. Make sure you ask me if you have any questions. I'm happy to come over to you, even if I'm teaching to the rest of the class. Raise your hand. I'm happy to come talk to you. Have a nice day, my friends. Bye.